You are welcome. I am Mafuyai of the Department of Physics, University of Jos. I'm going to introduce you an application called Mafuyai Graphing Tool. This application was developed in the Department of Physics, University of Jos, to help students achieve speed, accuracy, and ease when plotting graphs. Research all over the world has shown that students face problems when plotting graphs. So this was designed purposely to help students overcome these problems. If you have the application on your computer, on your smartphone or iPhones, you will see a logo with graph and abbreviation mark. That is Mafuyai Graphing Tool. You can look for it and click. You have this interface. Here is scale formula. You use this to find your scales. Table formula, you use this to convert your values into the millimeter equivalent of your paper. Slope and intercept formula, use this to convert millimeters of your paper into the equivalent of your values. If you want to watch video demonstration, you can use help. So let's see how you find your scales. You click here. Here, N is number of centimeters, whether on the vertical side of the paper or horizontal, depending on the scale you want to find. B is biggest value, S is smallest value, D is decimal place, T is turning point. For linear graph, no turning point, so T is 0. For quadratic graphs, you have one turning point, so T is 1. For sinusoidal graph, you have two turning points, but when finding the scale that will be on the vertical axis of your paper, T will be 2, and when finding the scale that will be on the horizontal, T is 0. Take note of this. For sinusoidal graph, you have two turning points. However, it is only the scale that will be on the vertical that you use 2, and the scale that will be on the horizontal, T will be 0. When T is multiple, to get basic scale you use MT as 0. Thereafter you can use numbers such as 2, 4, 5, and so on to get multiples. GR stands for gradient. When the two variables that you are plotting have the same trend, then GR is 1. But when the two variables have different trends, then GR is -1. So let's see how you get this, assuming you are given this paper and this data. To get your N that will be on the, when determining your scale that will be on the vertical axis, you find your N this way. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. To get the scale that will be on the horizontal axis, you get your N this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, let's say you are asked to plot log T against L. If you look at column L, the biggest value is 90.00, so B is 90.00, and the smallest value is 50.00, so S is 50.00. The number of decimal places you have here, you have 2, so D will be 2. If you look at column log T, the biggest value is 0.1973, so that gives you your B, and the smallest value is 0.1754, that gives you your S, and you have 4 decimal places here, so your D here will be 4. If you look at the two variables log T and L, you discover they have different trends. L is decreasing downward, log T is increasing downward, so GR will be -1. But if you look at L and log L, you discover they have the same trend. Both of them are decreasing, so in this case GR will be 1. And if you look at T and T square, they have the same trend. Both of them are increasing downward, so in this case also GR will be 1. So that is how to get your GR. So let's see how you find your scale. For instance, for the horizontal axis, you come and click your scale formula. We said the n for the horizontal was 20, b, which is biggest value, 90.00, s, which is smallest value, is 50.00, d, 2 decimal places, turning point, you put 0 because most graphs in physics practicals are linear. MT, you get basic scale by using 0. GR, based on the two variables, GR is -1 because they have different trends. So you click. This gives you 1 centimeters to 4 units with origin from 48. It's not every time that origin must be 0. If you have data that origin will be 0, the graphing tool will automatically give you that. However, if the question necessitates that you start your origin from 0, what you need to do is to only pick your biggest value from your table, and the smallest value you set it as 0 like this, and you click, you see it gives you origin that is 0. So take note of that. Plus C means you should leave 19 centimeters on the positive side of the axis. So in this case, we will leave 19 centimeters on the positive side of the horizontal axis. Now if you look at it, after 1 centimeters you will write. So it means that the axis could be clumsy, so your work can be dirty and you may lose scope for clean work. So to do this, you can decide to use multiples. So you can use multiples of 2. This means 2 to 8. You could use multiples of 4, which means 4 to 16. You could use multiples of 5, which means 5 to 20. Somebody could decide to use submultiples such as -2, which is 0 to 2. However, this cannot be a good scale because that will make the axis more clumsier. So the base could be 2 or 4. So let's say you decided to work with multiples of 2 like this. So this will be your scale that you use. So to transfer your scale, let's see how you do this. Now, the graphing tool says you should leave 19 centimeters on the positive side of horizontal axis. So you count 19 centimeters this way: 1, 2, 3, 4, 5, 6, up to 19 here. So this vertical line is to be drawn here. However, I'm not drawing it here because I want to leave out some space here to show you something. But the right thing is that the line should be drawn here based on what the graphing tool says. If you find that of the vertical, you discover that the graphing tool shows you that you should draw your horizontal line here. So once you have that, you can transfer your scale. So to transfer your scale, the first thing you do is to write the value of your origin in your calculator. Then after every value of your I, then you add the value of K on that origin. For instance, your origin is 48, so after 2 centimeters we add 8, then we have 56. After another 2 centimeters we add 8 on 56, we get 64. After another 2 centimeters we add 8 on 64, we get 72. You continue that way until the positive side is exhausted. Now to move to the negative side, you come and write 48 again in your calculator. After every 2 centimeters now you subtract the value of K. So this place will be 40. After another 2 centimeters you subtract, this place will be 32. After another 2 centimeters you subtract, this will be 24. So that's how to transfer your scale and transfer it accurately. Once you finish transferring your scale for both axes, then you are set to plot your points. So to do this, you convert them into the millimeter equivalents so that you can. So you come to table formula. Here, K is the same with the K you used. Here, K is the same with the K you use. O is the same with the O you use. I is the same with the I you use. But eta is the number of millimeter boxes inside your graph paper. If you look at the graph paper we have, it has 5 millimeter boxes. However, some graph papers do have 10 millimeter boxes. That is the small boxes inside the graph. inside the centimeter box. So if we are to convert our values of L, then we write our K, which is 8, our origin, which is 48, eta 5, our I, which is 2. Then we set this as constant so that we don't need to write them again and again. Now you convert the first value, which is 90. What are the millimeter values that are equivalent to 90? So this gives you 52. It means 52 of the millimeter boxes from where 40 is, that is from where your origin is equivalent to your 90. Then 80.00, here should it be plotted. 40, all you need to do is to count 40 of the millimeter boxes from the origin. You define 80. The next one is 70.00. All you need to do is to count 28 of the small boxes from the origin. You locate 70. So you do this until you get to the end, and then do that of the log t axis. Then you are set to match your point. So let's see how you match your points. Now the first one says you should count 52. You will locate 90. So this is 5, this is 10, this is 15, this is 20, 25, 30, 35, 40, 45, 50, 51, 52, and then you count upward to locate the point there. The other one said you should count 40 of the millimeter boxes. This is 5, 10, 15, 20, 25, 30, 35, 40, and you can see this is where 80 is, and then you count the other point. You count upward, you locate the point here. That's how you continue this way, and then your points are correctly matched. Now, having matched your points, you are set to get your line of best fit. To get your line of best fit, you look at points that are collinear, and then you pass your line through them. The remaining points that are not collinear should be distributed evenly above and below your line of best fit. Like in my own case, I have 5 points, and I'm passing my lines on 2 points that are collinear. So I'm left with 3 points that are not collinear. So the 3 points must be distributed evenly. So 1 point that is above, you can see that is farther away from the line than any of the 2 points that are below. You see, these points, 2 points that are below the line, they are closer to the line compared to the 1 point that is above. In this case, my line is a good line of best fit. I can score. Another candidate could decide to take these 3 points that look collinear, so that this point will be below and the other point will be above. Such a candidate also can be considered for line of best fit, and he can score. Now, once you get your right line of best fit, you are set to get your slope. So to get your slope, first thing, you have to draw a good right angle triangle that is reasonable enough. If you look at my right angle triangle, it is good and it's big. So in this case, I can score. So your right angle triangle must be a right angle triangle indeed, and must be big enough. So in this case, one can score. Once you draw your right angle triangle, the next thing is to find your coordinates. That is log T1, log T2, L1 and L2. So to do this, let's say you want to find L1 and L2. All you need to do is to count the number of millimeter boxes that from the origin to where L1 is, and also count from origin to where L2 is. And if you are to find intercept on the horizontal axis, you also count the millimeter boxes from origin to where the intercept is. Now, if you look at it, you have 5, 6. So you have 6 millimeter boxes to L1. You want to get to L2, you count, you find out that it is 48. If you want to get to the intercept, if you count, you discover is 68. So what you do is you come to your slope and intercept formula. Here the k is the same, you use k as a. O was the same, you use as 48. Eta is the same, 5. I is the same, 2. So you set this as constant, and then leave it so that you don't write again and again. The first one was 6, so L1, what is the value of L1? You see is 52.8. The second one is 48, that is L2. What is the value of L2? So you see is 86.4. Your intercept is 68. So what is the value of your intercept? Is 102.4. So that is how you use this to get your values accurately. Now, one thing you need to do is when you count the limiter boxes from the negative side of your paper, then you substitute with minus. For instance, you count say 5, 10, 50, 20. Then what you need to do is to substitute with a negative. Say you write minus 20, and then what will be the value? You see the value is 32, which is the same with the value we had when we are transferring our scale. So that is how to use this, to plot your graph accurately. Thank you. If you find this helpful, you can tell other students about it. For your mobile devices, you can go to the respective app store and download. Bye.